This is Algebra Lesson 3-5, working with sets. Now there's some vocabulary here that we're going to go through that you've probably not seen before, so it might be a little odd at first, but just bear with us and we'll be fine with it. Roster form is one way to write sets in which the elements of the set are listed in braces. For example, if I say the set of the multiples of 2, we would put that in roster form by just having a bracket, and then you would write 2, 4, 6, and then you'd have your ellipses points. The 3 ellipses points in English means something is left out, and in math it means it continues on. So that we're trying to tell you it's continuing on in that pattern, and then of course you'd end your bracket. And I'm not really good at drawing those brackets, as you can clearly tell. Do your best at them. I understand they are sometimes not easy to draw. Set builder notation is a way to write sets that describe the properties an element must have to be included in the set. So if we're talking about the multiples of 2 again, we'd start with the bracket, and it would be all values of x, and then we write a vertical line, which means such that x is a multiple of 2. You will do a lot of set builder notation when you get to Algebra 2 class, pre-calculus class, and higher level math classes because they like set builder notation. An empty set, sometimes referred to as a null set, is a set that contains no elements. It can be written in one of 2 ways. You can have brackets that have nothing in it, or you can use the null sign, which is a 0 with a line, diagonal line through it, meaning it's empty. The universal set is, in working with sets, is the largest set you are using. So if you're working with real numbers, that would be your largest set. If you're working with integers, that would be your universal set, which means you'd be only working with positive or negative whole numbers. The complement of a set is the set of all elements in the universal set that are not in your original set. Okay? So if I said the complement of set A is what we call A prime. And prime just means you're going to add a little apostrophe to it. So A prime. Now, in working with sets, this is something that's probably going to be a little bit new to most of you. So we'll go slow, and hopefully it'll start to make sense as we're going through this. Sets are the basis of mathematical language. You can write sets in different ways and form smaller and smaller sets or larger and larger sets. You can also describe the elements that are not in a given set. Okay, so we're going to take a look at a couple of problems, and we're going to try to write them in the right form. So we're going to use roster notation and set builder notation on these first couple of examples. And it tells us that n is the set of even natural numbers that are less than or equal to 12. Remember, natural numbers are your counting numbers. No fractions, no decimals, no negatives. Okay, and no 0, because we don't start with 0. How do you write n in roster form and in set builder notation? Okay, so let's do roster form first, because that's the order they asked us to put it in. So roster form for set n is n would equal, and we have to put those funny little brackets, which I'm much better at drawing one direction than the other. And we're talking about our counting numbers that are less than or equal to 12. Well, we're talking about even numbers. The first even number that's bigger than 0 is 2. So we would be thinking of 2, 4, 6, 8, 10, and 12, because those are the even numbers that are less than or equal to 12, that are counting numbers. So that's how we write it in roster notation. In set builder notation, which I'll just call set for right now, set builder notation, n would be equal to, in roster notation, you give the numbers, and in set builder notation, you give the words. So set builder notation is going to be all values of n such that n is an even number. And you could use x if you wanted to use x. You just have to be consistent with it. An even natural number, and I'm going to abbreviate number. And I'm going to say, and I also have to tell you that it's less than or equal to 12, so I'm going to use the inequality symbol there. N is less than or equal to 12. So one is using numbers and the other one is using words. That's the difference between roster notation and set notation. Roster notation, you just literally give the numbers that fit in that set. Set notation, you explain the numbers that fit in that set. Okay, so let's look at number 2 here. Number 2 says, in set builder notation, how do you write the solutions of 9 minus 4n is greater than 21? Okay, so in order to do set builder notation to this, we have to solve the inequality first. So let's do that first. So if I look at this, I have to subtract 9 from both sides. So I will subtract 9 from both sides. That gives me negative 4n is greater than 21 minus 9, which is 12. Divide by negative 4, and remember, when you divide by a negative number, that inequality symbol must reverse. So now I have less than negative 3. That's how we wrote our answers at the beginning of this chapter. So now with set builder notation, we're going to write our answer in set builder notation. And set builder notation is normally the ones with the most of the words. So I'm going to say set builder notation, all values of n such that n is less than negative 3. That would be the solution in set builder notation. This is the type of notation that we're probably going to write a lot of our answers in after this lesson. So just get used to that we will write many of our answers in set builder notation. I will not mark it wrong if you start solving all your inequalities and equations in set builder notation. That would be fine with me. All right, so let's take a look at another example here. Now you know that a set A is a subset of set B if each element of A is also an element of B. For example, if I have set B is negative 2, negative 1, 0, 1, 2, and 3, and A is negative 1, 0, and 2, then A is a subset of B, because if you look at it, A has negative 1, B has negative 1. A has 0, B has 0. A has 2, B has 2. So A is a subset of B, but B is not a subset of A. Because all the elements of B are not in A, but all of the elements of A are included in set B. And you can write this relationship as A is a subset of B. And it looks like a capital U sideways with a line underneath it. That's the symbol for saying that it's a subset. Okay, so what are the subsets of S if S equals A, B, and C? Right? Because if you look at this, you're looking like, okay, so here's what we've got. We have to understand that the subset of S is A, B, C. So we think about this and we go, okay, what are the possibilities of subsets? Okay, we could have the following subsets. We could just have A. Or we could just have a set that has B. Or we could just have a set that has just C. Or maybe we have a set that has AB. Or a set that has AC. And by the way, BA and CA are the same as AB and AC. Order doesn't matter. The letters in it do. So we have single subsets, we have dual, and then we've got the ones that we could have a trio of. Okay, so we have AB, AC, oh, and BC. I almost forgot BC. Silly me. And then we think about all the subsets that are 3 letters. So we could have A, B, C. Those are all the possible subsets of S. Right? Or there's one more subset. We could have nothing. Okay, we could have the empty set. That is also a possible subset. So if it asks for what are the possible subsets of set S, and then they give you that S is A, B, and C, a possible subset is that you have a set that has nothing in it, that has anything that, or it has A, or just B, or just C, or it has AB, AC, or BC, or it has all 3, A, B, and C. So that's all the possible subsets. Okay? So now let's take a look at something. It says, given that the universal set U is car, truck, van, school bus, and bicycle, and that set A is a set of vehicles that have 4 wheels, what is the complement of set A? Okay, so think about it. The complement would be vehicles that don't have 4 wheels. Okay, so we have 2 sets here. We have vehicles with 4 wheels. and we have vehicles without four wheels. Okay, which means they don't have four wheels. Anything other than four wheels. They have two wheels, one wheel, three wheels, 12 wheels, you know, anything that doesn't have four wheels. So if I think about this, right, we're looking for the complement of set A, and if set A is the set that has four wheels, this would be set A. And this would be the complement of set A, which would be A prime. So vehicles without four wheels is A prime. So if I look at the universal set of U, cars have four wheels. Trucks have four wheels. Vans, depending on how big they are, have four or more wheels. School buses, same thing, have four or more wheels. A bicycle, however, only has two wheels. Okay. So if you think about it, we can look at it, vehicles without four wheels. Well, I know that a car and a truck and a van always has four wheels, no matter what. So I know that the vehicles without four wheels, in other words, A prime, my possibilities are school bus, because if you've ever looked at a school bus, I have never seen a school bus that only has four wheels. Most of them have dual wheels in the back of the bus, even if it's a short bus. So it has at least six wheels. So we're going to put a school bus in there. And most bicycles I've seen have two wheels, sometimes three wheels, but I've never seen a bike with four wheels. Right? They may make one, but most bicycles, because it's called bi, means it has two wheels. Because a tricycle has three wheels, and then they give it a different name. Okay, so there's my A prime. Visually, let's look at what this would be looking like visually. Sometimes you've seen some of these subsets and sets drawn. Okay, we draw a big rectangle, and in the corner I put U because that's a universal set. Okay, and in the universal set, we have the subset of having four wheels, which is B. This would be set A. And what's in set A? Well, set A has car, truck, and van. Okay. And what does not have four wheels? That would be school bus and bicycle. Okay. So that's a visual picture of the universal set is those with four wheels. That's why you've got the big circle here, and the car, truck, and van fit in that, because that's the set A that have four wheels, and anything that does not fit into set A but fits in the universal set goes outside that circle, which is the school bus and the bicycle. All right, our closure question for this lesson. How can you be sure that you listed all the elements in the complement of set B? Okay. How can you be sure that you listed all the elements in the complement of set B? And don't tell me I have no idea because you didn't tell me what set B was. Okay, think about how you could do that without knowing what set B is, because it can be answered. All right.